Magnesium stearate, they put it on pills so that it coats it better, so that it goes down. Okay, so not all explanations for a knowledge claim are created equal. Some explanations involve more details and make more assumptions than others. In other words, they're more complicated. Assume you were confronted by two explanations for the same phenomenon. Both explanations seem equally plausible. Plausible means possible or likely, right? Which one would you select? The one that involved numerous assumptions and details, or the one that involved fewer assumptions and details? The one that was overly complicated, or the one that was more simple? The simple one, generally. If common sense tells you to select the explanation that makes the fewest assumptions, or the simplest, remember assumptions also require explanations, then you probably already have a good understanding of the law of parsimony, or Occam's razor. And this is an old but excellent example of the law of parsimony. Okay, so here's an old but excellent example of the law of parsimony. In the early 1900s, Mr. Wilhelm von Osten, a retired mathematics teacher, owned a remarkable horse, and his name was Clever Hans. Hans became world famous. This is a true story. Hans became world famous, and that is really hard to read. Why do I not have any spaces there? Hans became world famous because he could apparently solve mathematical problems that involved decimals, fractions, tell time, and read. Smart horse. For example, someone, his trainer as well as strangers, might ask Hans what 7 divided by 4 equals. Hans would tap the answer out with his hoof. I don't know how they did fractions. And receive a treat when he was correct, which was well over 90% of the time. Now, if I were to ask you guys without a calculator to tell me what 7 divided by 4 is, would over 90% of you get it right? I would hope so. Anyways, well done, John. The horse could do it. Okay, so a committee that included the noted German psychologist Karl Stumpf was appointed by the German government to study the phenomenal horse and prove that his so-called abilities were nothing but a hoax. The committee completed their task and reported that although they were unable to prove that Hans was receiving intentional cues, they remained unconvinced that he was able to solve such mathematical problems and complete the remarkable feats by using his cognitive processes. In other words, they couldn't prove it, but they were pretty sure the horse wasn't that smart. Stumpf's assistant, Oskar Funkst, I love these names, decided to continue investigating the phenomenal horse. Funkst conducted several experiments and concluded that when Hans could see the person asking the questions, he was able to supply the correct answer. If Hans could not see the person asking the question, then his performance fell to near zero levels. In other words, he couldn't even get close to the right answer if he couldn't see the person. Right? They put a wall up, and if the horse was asked a question, it was kind of, But if they could see the person, got the math answer right. Smart horse. Right? Funkst was faced with 2 alternative explanations for the horse's abilities. Either, 1, Hans understood the questions and was able to use cognitive processes, his brain, but only when he was able to see the question or solve the problems. His brain only worked when he could see the person asking the question. Or the person asking the question was somehow inadvertently cueing the horse. What does that mean, cueing? You're telling them what they're giving them a sign, right? Yeah, when to stop tapping his foot. Somehow inadvertently cueing the horse, when to stop tapping at the appropriate moment. Applying the law of parsimony, so as you apply the law of parsimony, which one of those 2 explanations do you think is most likely?
Second one.
The second one. How come?
Make more sense. Yeah, more sense.
Well, the first one seems a little extreme, right? A little crazy. There's a lot of sort of other explanations that's kind of complicated, other assumptions, right? The second one is clearly the more simple one. Applying the law of parsimony, Funkst chose the latter explanation and persisted in his investigations. He finally determined that almost everyone who asked questions of Hans made a minute upward movement of their head when the correct answer was reached. The horse used this cue to stop tapping and receive his treat. So as the person asks Hans, what's 7 divided by 4? And as the horse got closer to the answer, the person's head does what? Their eyes might get big, right? Or they kind of, oh, he's going to get it, he's going to get it. Yes, he got it. That's a little exaggeration, right? Is the horse pretty smart? Oh, yeah. But is he doing that? No. Do students do this all the time to teachers? Yes, they do. I'll ask a question. Is today the 15th?
No, it's
No,
16.
16.
Oh, you can see that there, right? But when I ask a yes/no question, people will say yes, and then they'll wait for me to respond. And if I go,
They'll say no.
and then I go,
But then
right?
they'll say yes again.
Students do this all the time. And you will try it with me, and I won't fall for it, because I'll give you the same response whether you say yes or no.
Alright, ask me yes for the question.
Am I the greatest guy ever, Cole?
Yep, we're in.
See, I did it there.
Did I say yes or no?
Oh, okay, fair enough.
I said yep, not yes. Well,
If you apply the law of parsimony as you evaluate knowledge claims, you are well on your way to becoming a good psychological consumer. Some additional points to consider, blah, 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 blah. Who cares? Okay. So you should understand the law of parsimony. Now here's where I sort of get into the extension part, because there's really no sense in me starting vectors today. So here's something kind of fun.
well, I guess so. Don't guess.
That's a calculator, right, Cole?
Oh! Looks like it. Yeah, it's out there actually.
That would be the simplest explanation, because why would anyone need a phone out when they're obviously being extremely entertained?
Hey, yes, he's talking to you.
Okay. Do you have this somewhere, Bayesian thinking? Somewhere? No? Okay, well, I'll just watch this one. Yeah, I don't think you have it. That's fine. Okay. So this is kind of an interesting little thing here too. This guy is the Reverend Robert Bayes. Your first thought is not always the right thought. People call, going with your gut, right? And does that often work?
Yeah, yes.
A lot of people believe in that, right? But sometimes you got to be careful. Pardon me? About 50% of the time, which would be like half, which would be exactly what you would expect if you just guessed. Right. Here's a couple examples. Two classic examples of Bayesian analysis come from World War II, oddly enough. The first involves the statistician Abraham Wald, that's him there, who was asked to determine where to add a limited amount of armor plating on bombers to protect them against anti-aircraft fire. So they had all these bombers, the Allies, the Americans, the Canadians, the British.
Obviously somewhere underneath.
Okay, so they said to the statistician, because statisticians do this kind of work, they said, where should we put the armor plating? We don't have enough to cover them all. Okay, so he did an analysis.
The vital areas.
Okay, so when a plane returned from a mission, the Air Force would record the location of all the bullet holes, and there's a picture that shows the bullet holes. So there was plenty of data. Furthermore, there were clearly more hits in some parts of the planes than others for some reason. So the answer was obvious. Put the armor plating only where there was a high density of bullet holes. In other words, put the armor plating like there, there. Okay, right? Makes sense, right?
Yeah, well, wrong though. Because what if they accidentally hit the other spot? Then you're screwed.
Then you're screwed. They accidentally hit the other unit anyway.
Well, I'm probably well.
So you're going with your gut and you're saying put the armor plating where the red holes are.
No, everywhere.
There's a limited supply. You can't put it everywhere.
Don't put the armor plating anywhere because you'll be faster without it.
Oh.
No, what you gotta do is you
Not
gotta
put the armor plating on.
protect the middle where the crew is, and then the engines. Protect the
On one
listening.
side and just fly with that side.
You don't need the section of
Yeah, just fly
Just
like.
fly in circles?
Who needs wings?
Well,
Side bomber.
here's the answer.
Like a tornado. Oh.
Obvious, but wrong. Do not put the armor plating where all the holes are. Here's the reason.
Oh.
He realized that he was only looking at data from planes that actually survived the mission. So they came back with all those bullet holes in those spots, but guess what? You can survive it there. So the planes that didn't come back, where were they shot down?
The other place.
The other places.
Right in front, right in front there.
Oh, at the cabin, the engine.
Gee, what do you know? Where the pilot is.
Still fly. Kind of need those.
Right? So when you stop and you think about it, you go, oh yeah. Okay, that's called Bayesian analysis, right? So don't always go with your gut. See if you can get the next one. This one's that one's an easier one. This one's a little harder. It's a little harder for me to explain too. I start with that one because it's easier.
I'm ready for a challenge.
Okay. Here's a second story. A second story relates to placing anti-aircraft guns and gunnery crews aboard merchant ships. So regular ships that are distributing supplies, food, fuel, whatever, right? To protect them against enemy bombers. So the regular supply ships were being bombed by the Germans, the opposition. Since both the weapons and crew training were in scarce supply, only a handful of vessels were equipped to test the idea for several weeks. So they put this anti-aircraft gun on some of the boats to see if it would work.
And they shot down.
At the end of the trial period, the gunnery crews were asked, how many planes did you shoot down? And the answer was, none. The entire plan was about to be scrapped when someone thought to ask a different question.
How many planes did you actually see?
And why does that matter, Cole?
You can't shoot down a plane if there is none.
And if they know that the guns are there, they won't come by there.
How many of the merchant ships in the test were sunk by bombers? Same kind of thing, right? As it turned out, the answer again was none, which was much lower than would have been expected otherwise. The ships were being protected, but not shooting down any bombers. Just like Ty said, the plane saw the anti-aircraft gun on the boat and said, hey, man, I'm staying away. So it scared them away, right? Apparently the enemy pilots did not enjoy flying through tracer fire, and the program was a success. And you see this type of thing every day. You've seen it in the cartoons. The scarecrow out in the field. What does the scarecrow out in the field do? Is it a real person out there scaring away crows? No. Right? Or you see the owl, the fake owl, keeping away the wasp nests. You see it in convenience stores all the time.
Fake cameras?
The fake camera, same idea.
Start the line here, not full of me.
Same idea. That's it. You're going to go and rob that place. Okay. Now, here's another good one. You have this in your package. This one's a little bit more fun. Okay? I forgot that I put all this together. Yeah, you've probably seen this trick. If you know the answer, don't put it up, okay? Suppose you're on a game show. This is an actual game show back in the 70s. And you're given the choice of 3 doors. Behind one door is a car. Behind the other 2, goats. Now, most people would choose the car ahead of the goats. If you like goats, great. Most people would prefer a car. I'm just saying the car is the prize. The goat is not the prize. Fair enough. You pick a door, say number 1, and the host, who knows what's behind the doors, opens another door, say number 3, which has a goat. So you pick number 1. He shows you either one of the other 2 doors. And then he says, do you want to pick door number 2? Do you want to switch, or do you want to stay with door number 1?
You gotta risk it to get the biscuit. So you gotta stay with your answer.
So you stay with your answer, says,
Pick the door he opened. Wait, but what if
only if you want to go.
What if the door he opened had the car though?
No, he would never never do that.
Your choice is he knows what's behind it.
Yeah?
Yeah, no.
No.
Big deal.
Yeah. You're right. Do they have it on? Yeah, like I want to watch. Okay, so here we go. So Cole, lead us off. Pick a door.
2. I'm gonna pick the middle one real quick.
Okay. So that's your pick. I'm showing you a goat. Do you want to switch or do you want to stay?
I'm sticking my gut. It's probably a goat, but I mean, hey, goat's pretty cool.
You gonna stay?
Yeah.
Gotta go.
Like I said, goats are pretty cool.
Okay. Who else wants to try?
I'll try 3.
Okay, Johnny. Pick a door. 1. Switch or stay? You're gonna stay. Oh, you want a car? Or a picture of a car. Anyone else?
I thought number 1 was the car, right? It's kind of funny.
Oh. Number 1 is on the right,
I
really?
thought you were showing me one first, so I thought you were showing me 2.
No. 1, 2, 3.
I still won.
Okay. So right now we're at, if you keep, we won 100% of the time. If you change, we won as well, right? Okay, so send me someone else. Pick a door. 3.
Number 2.
Switch or stay.
Hey.
Switch, you win a car.
So it's always number 1?
Always number 1.
Yeah. I don't think so.
Dawson, pick a door. Switch or stay.
It's always number 1?
Pick number 1 and stay. Is that what you're saying?
System's big.
Oh, this is lousy. You know what? It lets me to do 100 times here. Let's do 1,000 times, and should we keep or should we switch?
Keep.
Keep.
Oh.
Nope, they're all gone.
Why do we lose so much?
Because you would, in fact, you would lose 67% of the time.
How does that work?
67% of the time you would lose if you keep. What if you switch?
How does that work?
Oh, it can be. And oddly enough, if you switch,
How does that work?
65% win. Shall I explain it?
Yeah. Yeah.
Just play the video that was that's theoretical.
Yeah, don't forget to show that video show. Like,
Did you hear what he just said? It's just you basically said it's just a theory.
Well, yeah.
it is.
It is a perfectly good theory.
Is it because like the first time you got 3 choices and the second time you got 2 choices? Better odds out.
What are your chances of picking a car on the first one? 1 in 3, right? Well, you're pretty slim. 1 in 3, 33% chance. If all I said was pick a door, you'd have a 33% chance, right?
Yeah.
Holy cool.
1 in 3. Okay, so let's say you pick door number 1,
2 cents right
and then I open one of these ones, right? And one of them, right? I open one of these, guaranteed it's pig or goat or whatever, right? Now, I tell you, do you want to switch or change, right? If you change to door number 3, because you only got 2 choices, what is your chances of winning? Brett's standing in the way, but your choice of winning is now gone to 1/2, 50%. But if you stay, because nothing changed, if you stay, your chance of being right before is?
Makes no sense. You still have 50% chance.
No, because you've already picked it. If you pick door number 1, and then I show you door number 2, and then I show you door number 3, right? You had a 1/3 chance of winning. But because I give you that option to switch, now you're making a new choice out of 2.
But you're still 2. So it's 50.
That's what I'm saying. You've got a better chance if you switch. And it doesn't matter. I proved it. Well, I didn't prove it. I gave you evidence when I did it 1,000 times. And if I do it again, every time it's going to be 2/3, 1/3. Look at that, 67-33. And if I switch it the other way, keep, it's going to be the same thing. Okay.
I mean, if people were switching, you know what?
So, yeah, you should switch. You've got a much better chance if you switch.
Okay, so if I pick 2.
And then you can what?
If you pick 2,
What if I pick 1 though?
doesn't matter what you pick. I'm going to show you one of the other 2.
Yeah.
You still
Guaranteed to be. I will show you a goat.
You're still guaranteed a 50% win.
When?
After the first one. Yeah, after you first the first one, no matter what.
But you
share.
stay
No.
on your first pick, so it's out of 3 on your
Stay.
first pick.
It can't change. It was, you all agreed it was 1/3 when we started, right? Just because I opened this door doesn't mean that this is still 1/3.
Because then that's 1/2.
It's not.
How was it not? It's changed.
Now, interestingly enough, this has been around since the 70s, and you go online, and Brett's going to tonight, it looks like. Like, people that are way smarter than you and way smarter than me have been arguing about this for years. But it's pretty obvious, really. It's very switch. Especially now that you got computers, you can run it millions of times.
But when it gives you the like choice, stays you have half chance to stay, half chance of switching. Yeah, you got
Like, you have one big chance.
Yeah. Only if
Yeah.
you switch do you have a 1% chance. You're not making another. If you choose to stay,
Your first choice is 1 in 3, and then if you stay on your first choice, it's still a 1 in 3 choice.
that's right. If your first choice is what you're sticking with, your odds can't change.
Because you're locked in at those odds.
Like if I get a deck of cards and think of a card.
Ace of spades.
Ace of spades, excellent choice. Ace of
That's the
spades.
luckiest card.
Oh, I'll show you a magic trick.
Okay, and what are your chances of being the first card?
Very fun.
You're like a magician.
1 in 52, right?
And now it's
Right? Now it's 1 in 51. right?
Sticking with that.
But because you're sticking with that card.
Oh, you do have it, right? Okay, I see your point.
No, and then if you switch it, then it's still
But
one.
if you switch it, you'd have to put a card back in.
Yeah.
That's right.
You'd be choosing out of all the cards on the deck.
And you wouldn't choose this one.
Yeah. Got it.
I'm sticking with this.
Choose
You go right ahead. Go for you, my friend.
Go for you.
Oh yeah.
I'm fine with it.